between some questions across all of us. So I think we should be okay.
Yeah, hopefully the teams will answer and then this answer other questions too. Okay, so we're going to let them in and then we will start with the first video. Great. Thank you. Welcome. Hello, everyone from iGEM Tec QRO. Please, if you can open your cameras. We have the judges here, and in a few minutes, not a few minutes, a few seconds, I will share your promotional video, and then you will have 20 minutes to answer questions from the judges. I will let you know once we have 10 minutes left, 5 minutes left, and 2 minutes left. So good luck, everyone. I will start sharing the first video.
En los últimos años, México ha sufrido los efectos de dos graves pandemias que no solo han afectado al sector salud del país, sino también a la calidad de vida de los mexicanos.
La primera pandemia es la diabetes tipo 2, enfermedad padecida por millones de mexicanos que es clasificada como la tercera principal causa de muerte en el país y la principal responsable de amputaciones en México por heridas y pie diabético. Además, la enfermedad tiene una prevalencia que seguirá aumentando en años venideros dentro de la nación.
La segunda pandemia es la del COVID-19, donde además de los impactos en el sector salud, esta enfermedad ha ocasionado un grave problema al medio ambiente, pues el desecho de más de 60.000 toneladas de cubrebocas por semana en un país con un sistema de gestión de residuos rebasado ha ocasionado que los cubrebocas, que demoran más de 400 años en degradarse, terminen contaminando diversos ecosistemas.
Nuestro equipo, con el apoyo del TEC de Monterrey Campus Querétaro y NatProLab, decidió contribuir a la solución de ambas problemáticas por medio de la creación de RevioMat.
En este proyecto se utilizan los compuestos alifáticos derivados del polipropileno, que compone a los cubrebocas, como la principal fuente de carbono en un medio de cultivo donde crece la levadura Yarrovia lipolítica.
Este organismo ya posee la capacidad de degradar compuestos alifáticos, pero mediante la biología sintética se consigue que la levadura logre convertirlos en el bioplástico PHA. Esto mediante la introducción de un cassette de expresión, el cual cuenta con la secuencia codificante de la enzima PHAC proveniente de la bacteria Pseudomonas aeruginosa, que permite esta expresión tanto en peroxisomas como mitocondrias para alcanzar un mayor rendimiento.
El PHA resultante es un polímero biocompatible con una gran resistencia, poco espesor y alta transpirabilidad que lo vuelven ideal en la producción de parches para cicatrización en heridas diabéticas que puedan salvar a los pacientes de una posible amputación.
De esta forma, y gracias a la biología sintética, el proyecto evita que los cubrebocas terminen en el medio ambiente al utilizarlos como materia prima de productos que ayuden a mejorar la salud y calidad de vida de todos los mexicanos diabéticos que forman parte de nuestra comunidad.
Thank you. So we have 20 minutes starting now, and the judges, please raise your hands if you want to start asking questions. Yes, so we'll start with Deborah.
Hi, everyone. I'm really happy to be here. I think you're doing great, but I do have a question about, so my understanding is you will use only a part of the masks, and what will you do with the rest of it? What will you do to stop the waste to generating microplastic, for example?
Is there anyone from the team who would like to answer this first question? I think, Maggie, we cannot listen to you. No. Is there anyone else who would like to answer while she...
Yes, of course. Hi, we've been talking a lot about how we can reduce our environmental impact, especially because of the type of compounds we're working with. are like kind of complex when talking about pollution and plastics and stuff like that. We are confident that the part that we are using like pyrolysis for degrading our like feedstock, the face masks, we can also have like some sub-products. For example, for the part of the solids that we get out of this process, we can like recycle it and make something like biochar or like functionalized set like a sub-product. And this continues with our idea of generating bioeconomy or entering these like other sub-products of our own process into a circular economy like model.
Thank you, Cassidy. We'll go to the next question from Sophia.
So thank you for that answer. I also had that question. My question is more on your choice of use for the PHA. You mentioned using it for medical processes and medical products. Have you thought about alternative uses, since medical products usually take quite a long time for testing and regulation approval processes? Is there an alternative use, especially for generating revenue in the early stages, if you were thinking about doing a startup, as you said?
Team members, anyone who wants to answer this question?
Because it's biodegradable, we were thinking maybe we could use it as a biofilm to cover fruits and vegetables when they are in the cold chain from the agriculture part to the farmers market or the supermarket they end up.
Thank you. Catherine.
Hi, great project and presentation, everyone. I have a further question about the polypropylene as a starting material. You mentioned that the plan is to use pyrolysis to break it down. Could you talk a little bit about what's known about the molecules that would come out of that pyrolysis and how it compares to the aliphatic compounds that your organism is already known to degrade?
We have seen in the literature that pyrolysis can break down the polypropylene into the aliphatic compounds that we were talking about in our video. So it can create, for example, from 8 to 14 carbon chains, aliphatic compounds. And that's the reason why we are selecting this process, because once it enters our yeast, these aliphatic compounds of 8 to 4 carbon chains, they will transform into oil. Well, no, that's not the word. Into yeah. I'm sorry, I got the ácidos grasos in English. I don't remember the word for that.
Thank you.
Yes, no worries. Fatty acids, yes. Thank you. Joshi, please.
Yes, great project. I think it's very creative. Thank you very much. I have a question about your modeling. I see that you did protein modeling, docking simulations, and also bioprocess simulation. For docking, it was pretty clear what the outcome, the advantage of your simulations were, but can you explain very simply what the purpose of the bioprocess simulation is, and what are your results that you got from it that would help your project?
Yes, team members, please go ahead to answer the question. Is there anyone from the team who would like to answer this question?
Oh, yes, I answered the question. In this way, the firm that we modeling the production of PHA, it's use MATLAB. Here, in this way, we use and take some parameters that we take from some papers that are some authors that report the same circumstances that we want to pretend. And in this way, we modeling the three parameters, substrates, biomass, and oxygen that use the process, and helps to make or have a great conditions that helps to have a more sorry, I forgot the word in English, but best rendimiento in the production of PHA in less time.
Yes,
Okay, thank you.
the best deal, I think. Thank you. Let's go ahead with Guillermo, please.
Thank you. Yes, it's yield rendimiento. And thank you for the project. It's really interesting. I can tell to you that this topic was my undergraduate research project, also really similar to, I have a lot of questions, but will be more simpler. Can you tell me more about the PHA or the type of PHA you are obtaining or planning to obtain? Because there are several types of PHA. Can you tell me more about the properties of the material that you're expecting to work with?
We have seen in the literature that the PHA that you can get from Yaroba politica is more flexible than the one that you get, for example, from Pseudomonas aeruginosa, even though it is the same enzyme. So we are expecting some characteristics that are similar to what we saw in the literature. And we also know that PHA is biocompatible. That's the reason why we could use it in the wounds of diabetic patients. And it is biodegradable, so that's another reason why we are selecting this bioplastic.
Thank you.
May I do a follow-up questions to?
Fast follow-up, yes, sure.
Yes, it's mainly, so if PHAs are really nice, you can work with them, why they are not being used in the industry or in the medical applications? Thank you.
It is because of the cost. It is very expensive to produce, and that's the reason why our proposal could be useful for the medical industry, because we are taking a waste that it is a waste from the medical industry. So that's a cheaper substrate than the one that it is being used. And we are also proposing the production in 2 organelles at the same time in a yeast. So that's expected to get a higher yield than the one that is produced, for example, from bacteria.
Okay, thank you.
Thank you. Just to let you know, we have 10 minutes left, and we'll follow up with the question from Luis.
Hey guys, just want to say, love this project as well. I've also been working with Euro for the past year and a half, so hit home for me. My question is, you guys have some designs that you proposed that all make sense. I'm curious if you had access to, let's say, a lot of DNA synthesis or the ability to test many different designs. Like, what is the design space that you would try to test through first, and why?
Yes, anyone from the team can answer.
We would like to test first the plasmids that we propose to be fluorescent, because we first want to validate that the localization signals can actually transport the enzyme to the mitochondria and to the peroxisome. And once we have demonstrated that, we would like to continue with the production of the PHA in both organelles. So we would start by expressing it in the peroxisome, which is the most conventional way, and then we would express it in the mitochondria to check if it is viable to do that. And finally, we would do that simultaneously to check if it can improve the yield if you produce it in both organelles at the same time, compared to when you produce it in only one organelle.
Thank you,
Thank
Oscar.
you.
Deborah, please.
Hi. So I think you're doing great. Don't be nervous, please. We all struggle with English. So I do have a question about the final product. So is PHA, the PHA you're producing, the final product? So in a way, are you thinking about combining it with other molecules that also increase angiogenesis or tissue repairing for helping with the patients, or is it your final product?
Well, yeah, the idea is to eventually we want to functionalize it and make it like a patch, like similar to the ones that are already in the market. So it can be like functional for our final users. But for that, we have to first get our like production going, make sure the material works. And then we are planning to get involved to the patients, our final users, into the design of the actual product, because we want it to be like as human as possible and as close to them as we can make it, because we want this to actually be a functional solution for them and not just something we made because we got a random idea one day.
Thank you. Sophia, please.
I haven't worked with these in a long time, but my understanding is that a lot of these media are defined media, and it's very hard to scale those media up for like industrial level production, which is what your end goal is. Have you thought about how this would translate to more like not defined media, more general media? How would the design be adapted for these new conditions if you're planning to scale up these protocols?
Does anyone from the team?
Me.
Yes, sure.
Okay, in this way, to answer the question, is we have produce in some scale that we have or take the conditions that we have in scale laboratory and in my industry. In this way that I mentioned, the MATLAB help us to have some conditions that we have the yield to produce the PHA in the way that help us and don't miss all the conditions and have the final results like is Cassie mentioned the patch and have the applications in diabetes.
Thank you. We have 5 minutes left and we'll go with the question from Yoshi.
Hey, great job, everybody. I know that's a lot of very hard questions, very technical questions. I have a question about human practice, actually, specifically collaboration. So I read that with other teams, you actually created a biosafety level kind of evaluation document in Spanish. Is that correct? Can you explain more about what teams you worked with and what your team did for that document? Maybe you can actually show it to us.
Yes, we actually translated a biosafety manual that was originally in English. And it's because in Latin America, everything, like the original material is in English and not everyone has access to a proper, like really good education in English. We wanted it to be more accessible for everyone. And we translated the 4 principal main chapters that we believe had the principal guidelines for a biosafety level 1, which is the biosafety level. Both teams, UNMSM from Peru, iGEM team, is working with a microorganism biosafety level 1, and we as well. So that's why we chose that. I don't think if any of my teammates has the document ready to show. I can try and find it.
Okay, that's fine. Thank you.
Yes, no worries. We'll move on with the question from Veronica.
Hi everyone, congratulations for your project. I really like it. So I have a question related because I've been working with yeast for my PhD thesis. Now it is done, but I have some concerns related to the production of the BHA because you are proposing a novel strategy to mitochondrial targeting of the enzyme inside the cell, right? So I have serious concerns related to the energy imbalance inside this part of the cell, because you are going to use the TF1 promoter, which is one of the top stronger promoters in yeast. So have you thought about this eventually problem you are going to face during the development of the part of the molecular biology? Thank you.
Yes, we based our strategy on another paper in which they already express another enzyme in the mitochondria in Yersinia politica. And we saw that they integrated the DNA in the genome of the yeast, just like we are proposing. And they also used the TEP1 promoter. So that's the reason why we decided to go with that pathway, because we saw that it worked for another enzyme in the mitochondria.
Can I follow up the answer, sorry?
Sure.
Because what maybe something useful that you can think about it is to use an inducible promoter rather than to use this kind of a stronger promoter. So just a suggestion, in case it is really, really stronger for the production, I'm going to promote this energy imbalance, you can use an inducible promoter. And there is a lot of promoters available for these. So a suggestion, kind of follow up of the answer. Thank you, guys.
Thank you, everyone. So I don't have any more raised hands from the judges, and we're only 1 minute left. So if you guys from the team, if there's anything else that you would like to add in these last minutes, you would like to say something to the judges, please go ahead.
I would like to thank all the judges, and just to mention more about the biosafety manual that Joshi asked. We cover the evaluation risk of like the 4 main biosafety levels, and then the criteria on which everyone, the criteria used to choose which level to work within. And that's why when we were choose biosafety level 1, because in literature we review that Yersinia politica, which is the organism where we would like to work with, falls within that category of level 1. And that's what you're viewing. It's the main authors of the original biosafety manual. And there's also the 4 chapters, the 4 main chapters with the criteria.
Great. Thank you. Well, thank you everyone from the team. Thank you to all the judges for the great questions. So we will finish this session now. You can follow the next teams in the YouTube streaming that we have already is running. I will ask the team members to please leave the room, and we will have a 5-minute break waiting for the next team to join in. Thank you, everyone.
Thank you.
Thank you. Bye.
Thank you.
Bye.
Thank you. Goodbye.
This is the run get coffee break, I'm guessing.
Sure, you can go and get your coffee now.
So are we coming back on the hour? Is that?
Yes, we're waiting for the next team to join in. So we will have around 3 or 4 minutes until they come, and then I will start sharing the video. Thank you everyone for your patience. We will have the team members joining. Georgette, can you ask, disconnect. Georgette, can you ask your team members to please put the name of their team next to their name so we can let them in, please?
Yeah, sure. We're only two members. The other is trying to get in the room.
Okay, great. Welcome. Welcome from IberoPuebla team. I will start sharing your promotional video in 1 minute. And after we finish with that one, then you will have 20 minutes to answer the questions from the judges. So if there's anyone from your team that's missing, please just let them know they have to put their names, their team names next to their name, so we can let them in the room. Thank you. We'll start sharing the video now.
We interrupt these transmissions to give you an important bulletin for Coffee News. Coffee is the third most consumed beverage in the world, and Mexico is one of the top 10 producers. Focusing on Puebla, the third largest generator of coffee in the country, the municipality of Quetzalan is the one large producer in the state. This manufacture generates a lot of agro-industrial waste and is a great environmental challenge because its biodegradation requires a lot of time, special treatments, and releases pollutant. iGEM IberoPuebla has designed an alternative to convert this waste in a new material with the possible uses in the textile industry. Now, we are going to the lab where our reporter is with the team responsible for this amazing project.
Thanks, Granito. I'm here with iGEM IberoPuebla. They will explain to our audience about their project.
Good afternoon. I'm Samantha Jimenez, and along with my colleagues, we have designed a three-phase project. We started with a pre-treatment of the waste with Xylophagous fungi, known as white, taking advantage of their overexpression of enzymes to degrade the lignin present. Subsequently, a group of bacteria, Trichoderma sp, hydrolyzed the xylem present in hemicellulose, allowing the release of sugars. Finally, with the support of a third strain, Leucanacidobacter xylinus, which uses sucrose as raw material, we will produce bacterial cellulose to generate useful fibers or threads in the textile production.
Good job, team! You have decided to undertake an innovative process that transforms coffee waste in a new useful textile material for artisans, contributing to the economic development of the Quetzalan Puebla region. I invite you to pay attention to these talented students that use science to serve their community.
Thank you. So now we have 20 minutes to answer the questions. If any of the judges, if you want to raise your hand, then we can start with the question. Great, let's start with Deborah.
Hi, everyone. I really liked your project. So I have a question about the incorporation of this product into the artisans community. So do you think there will be any difficulties for them to use this new product? How do you plan to make them use this new technology in their production? Would you help them? How do you think, do you have any insights?
Well, yeah, we know that it's a traditional community, but we want to explore the part in innovation with materials, and
You're doing great, but now you're muted.
Yes.
I cannot hear you.
Sorry, we want to, as I say before. We want to innovate new materials, but we want to have work team with the team and the community. We want to work and collect and be a collective group. So I think there is our innovation with them.
Yes. You muted again.
I want to give the word to my partner.
Hi, good morning. As my team member said, we would like to have this relationship with the community and in the future have a partnership with them as we teach them how is the process made and eventually have something established on the community so they can work with it.
Thank you. We'll move on to the question from Sofia.
Hi guys, first of all, good job on your project. I really liked it. My question is more on the your choice of microorganisms, because if I'm understanding correctly, you want to use 2 microorganisms at the same time. My question is what is your strategy for culturing conditions, and also do you preview any sort of interference between the 2 organisms in terms of growth and byproducts of growth, one inhibiting the other and vice versa? A lot of the time that can happen. So is that something that you have contingencies against, that you have designed for? If you could run me through your strategy for that. And also,
yeah,
you're doing great.
For sure. As we mentioned on the graphical abstract, first we have a lot of difficulties by doing the project. For example, at first we established some methodology, and when we work, we thought that was not the best option. So at this moment, the strategy that we are looking for is first to have the strains from the ATCC to cultivate the bacteria that are the E. coli and the Gluconosectobacter hylinum, then make the transformation. And we thought of using a bioreactor to have the formation of the bacterial cellulose. This to have an increase of the pH to 6 and a temperature of 60 degrees. This to inhibit the production of the peroxidase to initiate the synthesis of the endoxylenases to depolymerize the bonds that are very abundant on these polymers. So the second bacteria, that is the Gluconosectobacter hylinus, is the intention is to help us have the structure of the I'm sorry, I forgot the word. The component to keep the resistance to the material that is formed. So the intention is to have both bacteria in the same tank. So it's only one bioreactor, changing the temperature and the pH according to the bacteria that is working.
Thank you. Great. Veronica, please.
Hi guys, congratulations on your project. I really like this project because coming from a country that produces also coffee, is a good idea to reutilize this coffee waste. So related to this project framework, do you have some numbers related to the percentage of coffee waste produced by this industry, and how much of this percentage you are going to use in your particular project? Do you have any idea or any numbers or something related? Thank you.
Like tons or
any idea? Maybe it can be in tons, in percentage, whether you have, if you have an idea.
Well, we know that the agro-industrial waste well, in Quetzalan, there is like this process of making coffee, but the coffee producers only use like 50% or 70% of the coffee. So the waste maybe we 30%, and that is like what we're going to use.
Thank you. Catherine, please.
Hi, terrific job, guys. That was really fun. I have a follow-up question to Sophia's about the co-culturing. The design, if I understand it correctly, is that the sugar is taken up by the second bacteria to produce the end product. How will you prevent the first bacteria from stealing all of the sugar?
Thank you for your question. That is something that we need to prove on the lab because it's something that we need to consider on the modification that we are going to make. By the time we don't know if that will work, then it's something that we need to check and consider. But we hope that we can continue with the investigation and the development of this project so that we could improve the design and do not have like this problem.
Great, thank you.
Yes, Luis, go ahead.
I guess I'll echo previous judges' comments to say this was a really cool project, really enjoyed it. I guess the question that I want to ask is related to Veronica and Catherine's question, which is, let's say you design all this stuff, you implement it, it's going well, and you're actually like executing this bioconversion. Do you have an idea of how efficient that process could be? So for instance, I have a kilo of waste. How much of that could you convert into your material? Do you have like any idea, like 50%, 20%?
Well, we actually hope that it can convert to 50% at least.
Thank you.
Thank you. The next one is Joshi.
Hi, as everybody said, really creative project. I think this is probably the first time I've seen coffee and textiles being matched together. So I think it's very local and very, very creative. It's a wonderful idea. I have a question about your optimization process for the biological design. So you use benchling, right? And I appreciated how you really purposely picked each part. You sort of tried to find and research the best parts to use. I want to ask though, what specific optimization are you making in the parts, right? And then as a second part to the question, what is your actual assembly mechanism? So how do you want to actually combine these parts? You talked about compatibility in your video. But what specific procedure do you want to use? Let's say you have the lab, you have all the supply. How would you actually go about doing it?
Yes, thank you. We definitely need to improve the part. We focus on the feasibility of being able to assemble the genes with E. coli in the design. We actually try to obtain most of the information from iGEM and past teams that uses this type of parts of the design. But we thought that the biomaterial market, it's not implemented on this section. Like for example, we saw that the design that they were made were concentrated on the biocombustible parts or the compost. So we thought that we can apply that method on the biomaterials. And also we thought that we could make a design not as specific because we identified that there are some agro-industrial waste that can be done with the same design that we are proposing. Like, for example, here in Puebla, agave is another industry that has a lot of waste. And we thought that with this design, we can like apply our design on different agro-industrial waste. And these could have like the opportunity to take into account another waste type of waste, and also like to support different types of producers.
Thank you. We have 8 minutes left, so we will move on with, I think, Guillermo, you have a question?
Yes. Yeah, I agree with Yoshi. It was a really nice project to read, really local, so congratulations. So the main question is about, well, if everything works well and you want to get the material from the bioreactor, what's the plan? How do you do it? After everything worked perfectly, you could control the proportions, no problem with bacteria, the material is there. What do you do with the bioreactor? What's next with your project?
Yes, anyone from the team can answer.
Could you please repeat the question again, please?
Yeah, no problem. It's mainly if you get how do you get the material from the bioreactor? The material is inside the bacterial strain, is outside. How do you get the material from the silk-like material from the bioreactor?
Yes, the purpose is that on the bioreactor at the top, the cellulose would be formed, and this is the cellulose that we would use, and we like to do this effect of force or spinning to obtain the fibers, and then have the bacterial cellulose or some fibers.
Okay, thank you.
Thank you. We have 5 minutes left, so we'll go with the question from Deborah.
Hi, everyone. So we all been saying that your project is really local and it's great, but I was also wondering, since we do have a lot of major producers in Latin America in general, like I'm from Brazil and we do produce a lot of coffee here. Do you think about expanding it? What are your plans for expanding, maybe having some collaborations with other Latin American countries on this project?
Well, like right now, we do not, well, we want to keep it on Quetzalan, but that's why we're like looking for a robust design, because we want to use this for different type of waste. So it's not only on coffee, but for example, we want to collaborate with another team here in Design League, which is one from Peru, that they are using to coffee waste and other producers, so they can use, like, we can have this bond and we can collab together.
Yes, great. Okay, so we have one question from Sophia now.
So my question is also going back to the genetic construct. If, again, my understanding is correct, you're using a plasmid-based system, and plasmid-based systems are known to be not super stable, especially if you're coupling this with a need to use antibiotic resistance. It might be not the best for scaling up, just in terms of costs. So have you thought about doing this as an integrated system? How would you address that issue?
Well, as you said, we may have missed some details, But from what we were able to review, we felt that this was like the adequate form to do it. We know that there are a lot of improvements that we can make. Thank you for your input. We are definitely going to take it into account. And for example, something that we missed and we saw that was important was like have some markers to identify these bacteria that are going to be modified, so we can like get to know where the bacteria are, and definitely the organisms that are going to be transformed. So we also, it's something that we need to review.
Thank you. We have 2.5 minutes left, so we'll move on quickly with the question from Yoshi.
Yes, so really quickly, good job so far. I know English is not your main language, and these are very technical questions. I have a question about human practice, integrated human practice. So you spoke to 3 different coffee producers, right? For your integrated human practice. Let's go back to the very, very first question that was asked about artisan growers, right? So if your team wanted to gain more insight, idea on how best to design your project, who do you think you should talk to? Has your team had a discussion? If you had more time, what kind of other people in the society you would talk to in order to design your project?
Okay, well, as we said, they are a community, so they work like in collectives. So they're like a community, a traditional community. So they need to get like involved with the project. So we thought that we need to talk with producers, with the artisans, that sometimes they are like families, like the same family. There are two like many how do you say, like collectives, I don't know how to say it, but there are some like assemblies that they made, and that's where we are going to start, because the assemblies are like there are coffee producers, there are artisans, there are engineers, there are architects, so cooperatives. Yeah, that's the word I was looking for. But yeah, with the cooperatives mainly.
Thank you. So we have 1 minute for one last question from Veronica, and then we will be finished.
Thank you, guys. I have a question related to the human practices part of the competitions, because I think this part of the competition is really useful and really insight. So do you think this part of the competition helped to your team and to your project? You got us some insights, some, I don't know, ideas that brought to the project and reshaped the project as well? Thank you.
Of course. I mean, this is the first time we are participating in this competition. Of course, we were like very nervous about the process, and we didn't understand as much as other teams that have a little bit of experience. But we think that all the comments and all the backup from all their teams helped us to get to the point that we are now. And we, of course, know that it's not perfect and that we have made past some things, and that they're important to consider if we want to implement it. But we are open to hear other comments and also improvements to the project, and also like relation from the other question, that helping with other teams could make like the project the best to get to the communities, no? Because the result is not for us, it's from them. So we think that the cooperative work between our community and others communities would help us, and also like this competition helped us a lot with Academy Learn. It was like the first tool that we used to improve all this stuff. For example, the things that we thought at first on the resume, then we work on the academy, and we thought like, no, it's not going to work like that, and that's why we make like so changes along the process.
It's great to hear also your feedback. So thank you everyone from IberoPuebla. We just finished with this session, and you can continue listening to the following teams in the YouTube streaming that's already online. So we're going to ask you to please leave the room, and we again will have a 5-minute really fast coffee or bathroom break for the judges, and we will move on to the last team for today. Thank you, everyone.
Congratulations. Thank you.
Thank you, guys. Yeah.
Thank you. Have a nice day.
Thank
Nice
you.
work.
Bye.
Congrats, nice work.
For the next team. So you can take this as a small break, 3 or 4 minutes, and then we'll start letting the new team in. Okay, we're gonna start letting them in 1 minute.
Thanks, everyone. Okay, so we are meeting the team members now. Hello, welcome. Biotech EC team. I'm going to give you a few instructions very quickly. So we will start in 1 minute. Everyone from the team, if you can open your cameras, that'd be great. Thank you. The first thing is that I'm going to share your promotional video with the judges. And after we finish that, you have 20 minutes to answer questions from the judges. So just please be mindful with your time. I will give you the heads up when we have 10 minutes, 5 minutes, and 2 minutes left. So yes, I will start sharing the video in 1 minute. Here we have, there.
Voy a hablarte de una solución para transportar los fármacos de compleja administración con simbiote diseñador. Si me preguntas qué es el Heparosan. Cientos de personas buscando la meta, ser la nueva industria que produzca esta, generando Heparosan de alta calidad. Y para su producción hay que tener precaución, por lo que la seguridad está en usar bacterias GRAS. Cuando el Heparosan abraza la medicina, la recubre subiendo su esperanza de vida. Sintéticamente es toda una maravilla. Heparosanito, Heparosanito está aquí para ti, para ayudarte, para ayudarte. Existe un problema silencioso que pocos conocen, son los efectos secundarios provocados por los medicamentos, por lo que Heparosanito llegó a ayudar. El Heparosan es un polisacárido natural precursor de la heparina. Tiene la capacidad de recubrir los medicamentos e impedir que se degraden dentro del cuerpo, mejorando así su asimilación. Pocas industrias se han potenciado para producirlo, por lo que iGEM Biotech EC brinda una solución. El objetivo del equipo es producir Heparosan usando E. coli Nisle 1917, una bacteria probiótica segura. E. coli es modificada genéticamente con biología sintética para que pueda expresar genes y biosensores que regulen el índice de polidispersión, lo que permite mejorar la productividad y calidad del Heparosan, haciendo posible su uso en la industria farmacéutica, con toda la bioseguridad dentro del proceso.
Great. Thank you. So we'll start 20 minutes now. So the judges, if you have questions, please raise your hands. We will start with a question from Yoshi.
Hi, sorry, I just really wanted to ask this question. First of all, great work on your project. You did a lot of work. I love the song in your promo video. It's a great idea. So I don't have a lot of biomedical background, so maybe this is a very simple answer. Is there anything that prevents the Heparosan from metabolizing into heparin in the human body? So you're using the Heparosan to, for example, coat drugs, right? So that it's more stable. But once it's ingested or taken in the body, would it actually metabolize into heparin and stop functioning as a drug stabilizer?
That is a good question. In fact, Heparosan does not degrade in the human body. That's why it is a great polymer to use for drug coating. And so when it comes to the human body in the extracellular medium, Heparosan does not degrade when it comes into the cell, and when it comes into the lysosomes, there's where it gets metabolized. And that's why it's a good drug coating, and it makes that the drugs that is coated with this will have a longer period of time on pharmacokinetics.
Thank you. We have a question now from Catherine.
Hi, great job, guys. That was really fun. I also really love the song. I have a question about your docking experiments. In the longer video, it looked like a molecule that should have been 3-dimensional was 2-dimensional in the protein docking. And I'm just curious to know more about where did your ligands come from, and did you encounter any problems getting the results that you wanted to see in terms of that active site remodeling that you were doing?
Well, about the docking, the ligands we obtain from PubChem, all the ligands, but we prepare these ligands in different softwares. One of them was Marvin Sketch, other was PVD does 2PQR. We don't have huge problems in this, only with the best score, but we solve it because we choose the best pose. Consider the score because we don't have any ligand previously for compare it, and we do it in this form because it was the best way.
Thanks.
Thank you. Veronica, please.
Hi guys, congratulations on your project. I think it's been a lot of work done there, and very creative ways to do it as well. So I have a question related to the design standpoint. It's not clear for me if the molecule, eparosan, is going to be secreted or be internally produced inside the cells. Thank you.
Well, eparosan will be is used by the bacteria because it's part of the capsule. But when is an excess of eparosan, the bacteria put it out of the cell. So in our case, in our bioreactor, the eparosan will be in the supernatant.
Thank you. Luis, please go ahead.
Hey guys, I guess first and foremost, I just want to say like the complexity of your genetic design, like your genetic circuits and everything, type 2S assembly, biosensors, you name it, you got like all the tools in the Symbio tool belt in this, and it's fantastic. My question is all of that complexity like really, really necessary? And two, a follow-up is, let's say you put all this together, your designs are in the cells, and it doesn't make any heparosan. Like, how would you go about debugging where the problem is amongst all this complexity?
Well, all our modules are necessary because we want to control the polydispersity index. And also we want to produce our eparosan when there is a high cellular density. So this is why we add the first module, hormone sensing. And the second one is to overexpress the enzymes that we need to produce eparosan. The third module is necessary to sense our precursors. And finally, your biocontroller module is necessary to control the polydispersity index in order to have equal amounts of our precursors. So yes, all of this is necessary. And but if we go to the experimental part, we can reduce our circuit, and maybe we can improve our mathematical models to make it short. Also, we try a mutation to erase one part of our model, so we can do it if we can prove more things. But as we have now, it's completely necessary each of the models.
Thank you.
Great. Let's move on with Deborah.
Hi, everyone. So I totally agree with all the judges. It's a very complex project, and you managed to make it beautiful and very easy to access. So really, congratulations to all of you. But I do have a question about the probiotic strain. So why would you need a probiotic strain if the bacteria, it's not going to be digested? If well, it's going to be the product. It's going to be oh my God, my English now is. You see, it's not only you who struggle with English, but purificated from the media. So could you please explain to me why would you need a probiotic strain?
Well, yes, of course. As you said, it is not intended for people to eat the bacteria, but we made some research and we found out that a person was being produced in species like E. coli K5 strain, which is pathogenic. So it is not biosafe or biocompatible. Therefore, we chose to use E. coli nisl because it is non-pathogenic as it is a probiotic. Therefore, we could ensure biosafety and biosecurity during our production.
I would like to add that we are working with a stakeholder, which is, for example, Noxgen, that is a company that also is interested in this type of biopolymer. So they want us to use this bacteria in order to diminish the risk for human health. And yeah, that's.
Thank you. Sophia, you have a question.
So my question is on one of the components that you mentioned on what your structure as a company, as a startup would be. You put in the income revenue or income source portion. You put in that you would basically sell the in silico model as your source of revenue. My question is, why stay there? This could be a platform for production of Iparasan for more than one application, and with the complexity of the design, and if it works, it could be like a platform for like specific design of organisms for like per request. So why that choice? Why does that make sense?
Excuse me, I can't understand. Can you repeat, please?
Yeah, no problem. So you mentioned that if you incorporate as a startup and if you want to do this, you would have your income source as the in silico model of this genetic pathway, which we all agree is very complex and really cool. But my question is, why wouldn't you keep this pathway yours and use all of the expertise as yourselves as like as a platform, as a synthetic platform developer company to sell the actual Iparasan? Like why stay at just the in silico design? Why not move forward and keep all of this as your intellectual property?
Meanwhile, as the team is deciding who is going to answer, I just want to let you know that we have 10 minutes left. So does anyone from the team wants to answer this question?
It's always better to start with the design part. So we just do it, and we looking forward to do it in an experimental way. Also, with this route, E. coli doesn't produce enough Iparasan to sell it. So that's why we design all our circuit to produce more Iparasan that E. coli can produce actually.
Thank you.
I would like to add something. Okay.
Sure.
We use model pathway from E. coli nisl. But however, we know that it can produce a parosan. However, in this model, there wasn't the last steps to produce a parosan, so we have to add it using Cobra. And of course, we base everything that we did in literature, and then we obtain the fluxes of the two precursors, and then we use it in the final dynamical model.
Thank you. We have a question from Guillermo now.
Sorry, can you hear me? Yeah. Really great project, really interested to read. I have really two questions, to be honest. The first one is, I'm not really convinced why did you use the quorum sensing circuit. I know how it works, why do you use it, but in here, in the whole process, why do you think it's necessary to use the quorum sensing method, considering Luis' question about the complexity of the circuit?
Well, it's necessary because we don't add another inductor, so we can produce this in a bioreactor, reducing the cost. So when in a bioreactor reach the enough amount of cells, our circuit will activate automatically. So it's an automatical inducer. We don't need to add any inducer to activate our circuit. That's why we choose quorum sensing.
Yeah, so following the question, so why not using, for example, constitutive promoters instead of the quorum sensing promoter? That's the main question is, why do you need to activate it? If there is something that if you activate it is toxic in a, I don't know, in that stage of the growth bacteria or something like that. So why do you need to activate this one?
Well, it's because quorum sensing is activated according to the density of cells. So we need that first our culture do what they need or produce what they need to live, and then when they have done it, they start to produce what we need. So that's why we add this quorum sensing in not an inducer or not a constitutive promoter.
Thank you. So we have, sorry, we have 5 minutes left. So we'll move on with the question from Deborah and then Joshi and Veronica if we still have time.
Can I add something about the previous question?
Yeah, it's really fast, sure.
Okay. Also, because in the bioprocess, the feedback process is the best, and with this quorum sensing, we can obtain this cell density that needs in the process.
Thank you. Deborah, go ahead.
Thank you. So in my understanding, the cost of this new way you're proposing will be higher than the current way. So my question is, do you have any insights on how to not make the final products, or it is the drugs, the medicines, being more expensive to the public?
So we know that our technology will in fact be much better and has lower production costs because we are currently using our design and optimized by our mathematical model. Also because our chassis will excrete the person into the medium, and it will reduce the cost in the part of purification. Also, we have advantage that we are using raw materials from Ecuador, from here, and to produce a paraffin, so we are low in cost in that part. And furthermore, the production of the heparin right now is using animal source. So by using a paraffin in this way, by producing paraffin in this way, we will help and produce in a more eco-friendly environment environmental way.
Thank you. Yoshi, please.
Sure. Sorry, I'm going to go very fast. We're running out of time. I see that you use flux balance analysis modeling, which I haven't seen a lot in iGEM. It's actually my thesis topic back in university. FBA, though, is oftentimes very inaccurate. And based on your FBA model, you came up with three very important parameters that you use for your dynamics modeling later on. That's my understanding. I want to hear more about how you did your FBA modeling with the Cobra toolbox. Did you have to do many iterations to fix, obviously wrong outputs, for example? How confident are you that your FBA modeling went successfully?
Well, first of all, we know that in the model there are initial parameters. So of course, what we do, adding the other reactions, we got a zero flux. So what we did was adjust the parameters to our conditions, and then we get the flux that we need, and that's what we used.
So did you do almost like a parameter sweep, just kind of adjusting different other parameters to see until you got the flux levels that you needed?
We just adjust the parameters that are about the fermentation. For example, about the carbon that start in the pathway, the
Sure.
nitrogen, this kind of things, and everything that is related with the conditions. So that's what we adjust, and then we get a flux that we need.
Okay,
Adding
thank
of
you.
that, we test different inputs expressed as glucose and oxygen. So to analyze change of the grain rate and flux of heparos and precursors. So these values tests were based on experimental conditions of the culture medium obtained from literature. So that's.
Thank you. We have 1.5 minutes, so that's the last question from Veronica. Thank you.
Okay, thank you guys for your answers until now. So I have a question, and more related to the follow-up question of Guillermo, I think. So you are proposing to use this fed batch strategy, right, to increase the biomass of the cells to produce heparos. And so have you read about if this high cell density could affect the quorum sensing module? So because I have that concern. So at some point you have a lot of biomass and you're going to saturate that. So, and that this is a really important part of the project. So that's my question. Thank you.
Okay, we know that there's a threshold that in which one the quorum sensing starts to is activated. Okay, so and we also know that there's another threshold on the top that restricts the growth of the cells. So, and we know that there and this is why there's so much important the time of fermentation. We use around 70 hours. I don't remember it well, but it's also important because we need we model everything about it, the time and the product that we obtain, and that's why we know how much we are going to get, how much person we're going to get, and how and what OD we're gonna obtain also.
Winning the next gen. The team winning the next-gen challenge allowed us the visualize to production of the product on a large scale. Using a substrate such as melassa allows us the optimizing cost. Heparosan and baking in an extracellular medium allowed us to reduce costs, in addition to implementing quorum sensing in the bioreactor.
Thank you, everyone. So we just run out of time. So I want to thank everyone. Thank you very much to everyone from the team. It was very fun and exciting to listen to you and to see all your videos and your projects. Thank you to all the judges who participated. The judges can stay in this room if there's anything that you would like to discuss further. We will ask the team members to please leave the room and just wait for news in the following days. Thank you, everyone.
Thank you. I can add something.
And congratulations.
Congratulations.
Just one more thing, and we did upload the time, the roadmap, but in the juggle it doesn't appear because we had some technical issues in the part of the juggle, so we want you to take into consideration that. But thank you very much for your time.
Thank you, Natalie.